Welcome to the section 1D. Continuing on the OS services, let us look at the following services provided by the OS. Then we'll touch upon resource manager. What is the role of OS in managing the CPU, memory and devices? Now, access to IO devices. So before I show you this structure, let us understand why do we need a controlled access to the IO devices. See, look at a CPU or maybe a computer system. Okay, we have a computer system. Now we have many IO devices connected. It could be a Wacom what I am using currently, or you may be connecting a pen drive, or even this display what you see is a IO device, and the keyboard and touchpad, everything is a IO device. Remember one thing, that all these IO devices that we have, either touchpad or even if you have a mouse, they are all shared by different applications. Imagine a small window and then you are typing something, or maybe you have a email open and then you want to send some email or read some emails. Everything is controlled by the mouse movements or mouse clicks. But where is the current mouse and then on which application it is being acted upon, based on that you are getting a response. If you have a terminal open and you are typing something, then it is a terminal which is receiving the command. Whereas if you have a web browser and then you are trying to read a Gmail or your Google Classroom, you are downloading some application. So based on the area which is active and you are trying to do something on it, the IO device inputs what you give, either from mouse or maybe what I am writing now, is all going to that particular application. Now who decides which application gets your mouse click or what you type? Who is going to get out of all these applications which are currently running in the system is decided by the OS. So since the IO devices are shared between different applications, and the OS, who is the master of what is being done on the system, it has every control on whom to give the input and when, which application should get the input, and then once the input is fed to that application, based on what it is programmed for, it responds. And then the response is also, if it has to be displayed on the screen, then that application need to take the control or take the help of OS. The reason is the screen what you see is being shared by multiple applications. So what is to be displayed on a screen needs to be controlled by the OS. So IO devices are not controlled directly by the application. It is with the help of with the help of OS, IO devices are controlled. In the sense, either you are reading from the IO device or you want to display something or you want to display a graphics, everything is done through the help of OS. So if I have to show you a typical operating system which is controlling the hardware, which includes all the IO devices, hard disk, keyboard, mouse, pad, everything that and including the CPU and memory. Now there is an object manager, because in the OS everything is treated like an object, because it's a object oriented programming which is being followed in OS parlance when they are implementing OS. So there is one manager, and then plug and play is a normal way how you are connecting. As you know, we are not doing anything special. When you just connect a pen drive, it is being recognized by the OS and then it opens up the directory structure of that. Or even if you want to download a file, you connect a mobile phone, and then you say that it is for the file transfer. Then the disk of or the SSD or solid state device memory that you have on your mobile becomes a directory structure on your laptop. So this needs a way of functioning without you getting involved or being involved in installing any device driver. It is being done by the OS automatically. That's called plug and play. Then security monitor, that means you know that in the background there are some virus scan is happening always. When you are downloading some file, automatically it says that you are downloading from an unknown source. Are you sure that you want to download the file? In fact, it does some screening of the file also to see whether this file is genuine enough or is it infected. So these are the things which are done by the OS without your knowledge in the background. Now all these device related files or IO manager is there, and device drivers are part of this. And then we have processes and threads, which will be spending a lot of time on it. That every application that you run needs to be in the form of a process or a thread and managed by the OS. And I already told you also that memory is managed, which is nothing but a main memory that you have in the system, which is also shared between different applications that need to be managed. So in general, everything that you see on a system is controlled by the operating system. And there are system threads which are OS specific threads which are initiated by the kernel and run in the kernel mode. So there are two modes which we will be spending a lot of time on it. Kernel mode is a special mode in the CPU which gives us special permissions and access to different instructions and the entire memory. So that's in kernel mode. Our OS always runs in kernel mode, and within the OS also there are multiple threads being created and managed. And then you also have applications which are in the user level. There are many processes and which are related to system, though that runs on the user mode, and they get when they move into getting services from the OS, runs in the kernel mode. And there are different applications. Even the PowerPoint is one of the applications which are running in the system. So this is a general overview. There is a special name which is called HAL. It's not Hindustan Aeronautics Limited. It is Hardware Abstraction Layer. This is to give you an abstraction of whatever may be the hardware below. It could be a CPU from ARM or Intel or AMD, or it could be the memory, 4 GB memory or 8 GB memory. Even the hard disk could be from Samsung or Western Digital, or it could be a solid state drive from Samsung or any other vendor who is providing the solid state drives or hard disk. So it provides an abstraction of those which are removing all the vendor specific details of the hardware that you are connecting it with the system. So hardware abstraction layer and device drivers and IO devices related programs which are handled by the OS, they help the application programs to interact with the hardware. So each IO device requires its own peculiar set of operations. So you see, suppose if you are having keyboard, every character that you print or a type has to be received. Whereas if you are reading from a file from the hard disk, then entire stream of file needs to be read. So devices are also categorized character device, which are receiving as single characters. Whenever you type, one character is coming. Even that itself will create an interrupt to the OS. Now, if you are pressing a Control C, it's a combination of two keys which is sent as a single character and it is being processed by the OS. Whereas if you are reading from a hard disk, it's a block of data which is categorized as a block device. So character device, block devices are two different categories of devices in the Linux environment as well as in other OSs being handled. Now, every device in Linux is treated like a file. So if you want to operate or read from a keyboard, it needs to be open and then you have to read it. And then suppose you cannot write into a keyboard, but if suppose it's a display, you will be writing into the display. But even to write into the display, you should open a device which is no display device. So this similar to that. Even the serial port you need to do it. If you are familiar with Arduino IDE, we open the COM port and we try to key in some characters, a command to the hardware, and whatever hardware is sending you back through the USB, though it's a USB is a physical interface, it is actually being transmitted over serial port protocol and it is being received, and then you will be seeing that on the IDE, on Arduino IDE, some command prompt or a serial port which is displaying some characters coming from your hardware. So these are all handled as a files in Linux system, as well as many of the OSs like Windows, they also operate in the similar way. So IO devices, I already mentioned about it. So OS provides a uniform interface for all the devices. So they abstract it out. That's what I want to convey in this particular service. Now, what about controlled access to files? See, even if you have files, maybe let me talk about the change mod, which is a command. We normally use it in Linux environment, and then we also have something like access permissions. We'll come to this later on. in case if you are not familiar with this, actually it provides a controlled access to the files, whether you have a read access, write access, or executable access. Whether you are a user, or a owner of the file, or you are a part of a group where the owner belongs, as well as others in the system. So based on which category you belong to, the user belong to, different access permissions are given, which is being represented as a octal number here. We will come to that later on, but just wanted to say that access to files relates to different kinds of access that you provide to a file: read access, write access, or execute permission. So even that, sometimes if suppose you are logging into your own machine, whereas there may be multiple users using your laptop and they may have a user login, then you may protect your own files from other users accessing it. So that kind of user specific access is also provided by the OS. So file system, how file is stored in the hard disk, and then like this particular session, when I am storing it in the file, it is being read by the PowerPoint application and then displayed on the screen. So OS reads the PPT file as a stream of bytes. So it's all stored in the hard disk as stream of bytes in a either contiguous segment or maybe in a different sectors of a hard disk, and then they are all grouped together and given to you from the device driver which is accessing the hard disk. And the PowerPoint program which is reading those bytes understands them and then displays it on the screen. So multiple users having a file, suppose you may be having a file server. All of you must be familiar with the Google, where we may be sharing some Google Drive where we may share some files and then provide some access permissions. So you may be sharing the file to specific users. In that case, only those users to whom you have given the share access permissions, those people only can actually look into the file. And you may also be able to give a read permission or write permission. In that case, based on the permission that is given by the users will have different kinds of access permission. So this is also supported by the OS and implemented by the OS. So even Moodle is one example where you may be a teacher or you could be a student. Then the Moodle implements it some kinds of access permissions, whereas when it is actually going into the file in the cloud, it is again some other OS which is running there and taking care of providing a controlled access to the files. So this is also one of the services provided by the OS. Now system access in general, when you are logging into a file or system, you first of all come across a login prompt where username is asked for and then the password is asked for. So this kind of interface provided for giving a login prompt is also done by the OS. So controlled access by the file through the LAN or a network, or even in individual system, we have access control supported by the OS. So password protection of even a file also has a password protection which is actually handled by the application, not by the OS per se. But if you are trying to give a controlled access to a particular drive or a particular system itself, then the OS comes into play. Whereas if it is at the OS level or a document level, if you are providing a password, then that password is protected by the application, which is maybe Microsoft Word or Excel sheet, which you can protect it with a password that is handled by the application at the application level. Whereas a system level accesses and the password that you have for login to a system is provided by the OS. So you should have a difference, understand the difference between who is actually controlling which part of the access. So resource contention, access function must also provide protection of resources, data from unauthorized users, and must also resolve conflicts. When I say resource contention, suppose you are on a Google Drive and then you are multiple users are editing the file. You may be making changes and other users also may be making some changes. So there shouldn't be mixing up of the changes that you are doing. So that is being handled by the application, the Google, Microsoft Word or Google Word or Excel sheet. When they are controlling the multiple accesses, sometimes applications take care of it. Whereas in the OS parlance, suppose you have a file and multiple users are changing it in a Linux environment, it also provides a resource contention, making sure that only one person gets an access to the file at a time. So restricted user access, not allowing a file to be opened for updates while same file is being opened by another user. Suppose you have opened it for updating the file, only one person should be allowed to write into the file. Otherwise, there will be a mixing up of data that has been if you are allowing multiple people to do it. So there will be a read permissions for multiple users, but only one write permission provided to the user. So these are the control accesses given by OS. And then error detection and response. Suppose you have written a program and then you have not initialized a pointer, okay, some int pointer you have initialized, you have declared, and without initializing, you are trying to use the PTR pointer and then assigning some value to it. Now you don't even know this pointer is pointing to which address because you are not initialized to ampersand of some variable into the pointer. Now in that case, what happens is when you try to write into this 100, the pointer variable is created already, so it has either 32-bit pointer or maybe a 64-bit pointer based on whether you are running a 32-bit application or a 64-bit application. This pointer content, whatever is there in this variable, is not initialized by you. So it may be pointing at any location which may not be within the range of your own process. In that case, it is you are trying to access something outside of your process. This will be caught by the OS, and in particular, it may be caught by the hardware which is programmed by the OS. So it tells the hardware that this process is now running and its own memory is only this range. If it is this process while running, if it tries to access anything outside of this range, please give me an exception. I will catch and then I will report it to the user. So this is what happens when you try to use a uninitialized pointer and try to access it and write into it or read from it, then you will get a exception called segmentation fault. Okay, these are the errors which are generated by the hardware, whereas the hardware itself is programmed by the OS to say that if this application tries to access anything outside the range, give me an exception. Then hardware informs the OS, and the OS in turn knows which application is trying to do this. Then it stops the application from running and then gives a segmentation fault to you. So these are some kind of error in case suppose you are accessing a file, you are trying to go to a path which is not even existing in your directory structure, then it gives you illegal path or file not found. That is also given by the OS. Now if you try to delete a file which doesn't exist, the error comes, which is actually given by the hardware saying that the file is not there, the hard disk device driver, then OS informs you that the file doesn't exist. So even the device itself, drive itself may not be there. Suppose you have connected your pen drive and then you are trying to update that some files into the pen drive, but in the middle you have removed the pen drive. Now what happens is it goes into that particular directory looking for a drive and then it doesn't find it, then it gives you an error. So these are the things which are handled by OS, and you should know when you get an error message who is giving the error message, for what purpose it is coming. So having a clear understanding of operating system and how does it function, then if you are clear about it, you will be able to appreciate all this behavior of the OS, and then you will also be able to write applications or software which is error free, and even if some error comes up, and while debugging it, you will be able to appreciate what is happening, why is it happening, and you should be able to fix the problem. Now, last but not the least, accounting. What is accounting? Now, suppose you want to know how much of disk space you have used. Somebody has to make sure that how much of free space is there, how much of is occupied. Then only you will be able to get that information. So this is done by the OS. Now, what about the battery? Now you know that sometimes when you are using your laptop without realizing that the battery is draining off, and then you have hardly some 10 minutes of battery left, it gives you a warning that you are running low on the battery. Now why is it giving you early warning? Because in case if you are in the middle of editing something and the battery goes off fully drained out, then all that you have done will be lost. Because remember one thing, I already many times told you that the programs are running from the RAM, and the RAM is DRAM or dynamic random access memory, which is able to hold whatever is the content only when the power is given to it. Now suppose if you remove the power or battery goes off fully drained off, whatever is there in the main memory is gone. Now if you are editing some file or you are writing a program halfway through and it's all being done in the RAM and needs to be written into the hard disk. If the battery goes off completely drained off, then whatever you have been editing will be lost forever. That's why it is giving you early warning, and if you don't respond to it or if you don't connect the battery or charger, then what happens is it automatically saves many of the things that you have done in the RAM into the hard disk and then shuts off the machine, so that when you bring it up later on, whatever changes you have done will be recovered. So these are the OS has to continuously monitor what is happening in the system, whether battery is running low or not. So in the background, whenever you are working your laptop, background the OS is doing lot many things than what you can imagine. So if you want to understand what all the processes running, how many of them are my own user process and how many of them are system processes or the OS processes, control or del you give, and then look at the number of processes running in the system, then you will be surprised to know that there are many more things are happening in your back in the background than the PowerPoint or whatever you are working on. So these are some examples. Now let me just tell you what is the kernel of an OS. Kernel is the most critical component of the operating system. When I say critical component, managing the CPU, managing the memory and IO devices are most critical, and those code which is or a part of the software which is developed within a part of the OS, they called as a kernel. Kernel is the most critical and innermost part of the implementation of the OS. It's a central part of the operating system. It manages the operations of memory and CPU. And by now, I think you will be able to appreciate why memory has to be managed, why CPU should be managed, because CPU is shared between multiple applications. Because you may have a multi-core processor, but still it may be a 4-core or dual-core processor. That means any application running in the system has to run on one of the CPUs if you have a dual-core processor. In that case, they need to be time shared. That is done by the OS and the kernel part of the OS. Okay, now time sharing of resources is most important job done by the OS, so that everybody gets a fair share of memory, devices as well as the CPU that is in the system. Though kernel is shown above the memory in the picture above, the kernel itself is a program. Remember, kernel is sitting here above the CPU and memory, but kernel itself has to run on the CPU and its image itself is in the memory. That's why some part of the main memory is always reserved before any application comes. Your Windows or any Linux OS is residing in your main memory. Remember that, and it is protected with the mode which is in the kernel mode, so that no other user applications can tamper with that and corrupt the OS. So kernel executes a scheduler, which is a part of the module of OS, which tries to make sure that every process in the system gets a fair share of the CPU. So if suppose you run a program which is an infinite loop, then what happens? Now, how do you write an infinite loop in a C program? You write while one and then say this is my code. What happens is this you are running this code forever. It doesn't terminate at all. In that case, if you are allowing this application to run on the CPU, what happens to this? This CPU will be occupied by your own process forever. In that case, the entire system will be locked out because only your process is running and no other process can run on the system. So OS monitoring all these things. If suppose a process is running on the CPU for a longer duration beyond some time quanta allotted, it's called time quanta. A quantum time allotted, maybe 10 millisecond or 5 millisecond based on how a scheduler is configured for, then when a process is running more than its scheduled time, it is forcibly taken out of the CPU and some other process will be run on the CPU. So these are all things done by the OS to make sure that the resources are time shared between multiple processes and multiple users. So effectively, OS is as a resource manager. It's giving you a fair share of your own memory. I told you that operating system is there in the memory. Your application is sharing the rest of it, because this cannot be taken out of the memory, because OS has to reside on the main memory to make sure that the system is controlled properly. And remaining IO and CPU are all handled by the OS. I hope you get an idea how OS is running on the system and how it is also making sure that nothing goes out of its control. Okay. So what happens is OS, though monitors continuously, it doesn't run continuously on the CPU. Please remember that the CPU cannot be running only the OS code. If it is so, then system is not doing anything useful, because we want the CPU or the system to make use of running the user applications, not the OS. Whereas OS has to be continuously monitoring what is happening. So it comes for a short duration and then gives the control back to the user process. At the same time, has a tab on what is happening. Okay. So It makes sure that user process doesn't take control of the entire system, at the same time giving access to the user processes to run on the CPU with a restricted access. It doesn't give you kernel mode access. And if any user process wants any services from the kernel takes control of it, and it runs in the kernel mode and gives the control back to the user process, and make sure that the mode is changed from kernel to user mode, so that user application never gets into kernel mode at any point in time. So normally we think a control mechanism as something external to it. Normally, if you say thermostat in a system where it controls the temperature of a boiler, it is outside a system controlling it. Whereas in this case, OS itself is part of a software which is also running in the system along with the user application, at the same time having a control on what is happening in the system. That's the uniqueness of this operating system, which is also a software, but it has a better control on the system. So how does it manage? It's a typical residential heating system is external to the entity. Now you may have a air conditioner which is sensing the temperature and then switching on the AC for a while and then switching it off when it becomes colder. But it is an external system. Whereas in the OS case, it's part of the system at the same time managing the system. So you can read through this content and you can understand how does OS differ from the typical normal control mechanisms that you have seen in a environment. So in order for the processor to do any of the useful things, I told you that OS has to run for a short time and then give the CPU for executing other programs. So OS gives up control of the CPU and it allows the other user processes to run on the CPU. So kernel contains the most frequently used functions of the OS, and as I told you, it's the most critical part. The remainder of the main memory contains user programs and data. The allocation of this resource or the main memory is controlled jointly by the OS and memory management. See, the memory management cannot be controlled completely by the OS because OS itself is a software. You suppose you are writing a program which is I told you an example of uninitialized pointer. Now, when you are trying to access a address which is coming from the CPU, either store or load instruction which is accessing the memory is happening at the instruction level. You can imagine that it is all running in gigahertz clock and it is in the nanosecond speed. Now, no software can control anything which is running at the nanosecond speed, right? So whenever any illegal access is happening, it is at the instruction level and it is at the nanosecond level where one particular instruction is misbehaving. It can't be caught by the OS, which is not even running in the CPU, because your user process is running on the CPU, right? OS is taken control, it has given the control to the user process on the CPU. So it's not neither controlling it or it's not running. You cannot have both OS process as well as the user process running on the same CPU. Either one of them should run. So what does it do? OS programs the hardware, which is a memory management unit. We will talk about it later, which always checks every access from the CPU, whether it's user process running on the CPU and is it controlling its own area or is it going out of the range. If it is a OS process running on the CPU knows it because it is in the kernel mode, then it doesn't give control the accesses because it knows that OS is running. Whereas if user process is running on the CPU, it checks always whatever access going on is within the limit or not. In that case, hardware only can find out if there is an error or if it is going out of the range, then it gives an exception and OS is notified. So the memory management is done by both the OS and the hardware together. So a good example of Windows 7 architecture. I am not going into the details of it. I just want to tell you that how complex an operating system can be. And you can see that these are all in user mode and these are all in kernel mode, and anything that is coming from user mode, if it needs any user application needs any support from the OS, needs to switch over from user mode to kernel mode and the kernel code runs. That's it. I want to know. I want you to be aware of at this level. Then we will talk about more in the future. Now, portable operating system interface, which is a very popular interface, which we'll be using it in our lab section. With actually, it abstracts out the OS. So whatever software you write, the interface that you provide is independent of the OS. You don't have to call Windows specific API or Linux specific API, which is mapped. POSIX interface is a generic OS interface which is independent of the operating system. Maybe I'll give an example of pthread create is a good example of an API which is used for creating a thread. But this pthread create itself is not anything specific to a particular OS. Whereas the pthread create, if it is running on the Windows, it may be calling Windows API to create a thread. If it is running on Linux, it will be calling a Linux specific system call to create a thread. So POSIX interface is a generic portable operating system interface which is independent of the operating system. That's what I want you to know about what is POSIX API. The reason why we use POSIX API is application that you write, you don't need to think about any OS underneath. You can just say pthread create. You don't even know what is the equivalent function call in the Windows, or you don't have to know what is the equivalent function call to create a thread on Linux. You just write your application as pthread create, and the POSIX library takes care of pthread library takes care of converting it into a equivalent OS function call and giving you the service that you are asking for. So your application that you write can be easily ported across different operating systems. That's the intent of having a POSIX compliant application. Okay, so there may be a 64-bit version or 32-bit version of application which we will touch upon in the lab section. So if you want to know different system programs running in the system, you can give this command on Windows platform and then look at different threads running in the system. And if you want to look at the details of each of those files, you can look at the properties and come to know about it. So this has given you an overview of the OS and how it is providing you all the help or services that you need. Okay, I hope it was useful. See you in the next slide, this section. Bye bye.